Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 141. Find the number of possible ways for any event. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. Yeah, I mean, this is clearly, honestly, a very mathy problem, right? There's no way around it. I think, yeah, I mean, I think, we'll go over the problem, but some parts of it will be a little bit combinatorial, just because I mean, it is the nature of the problem. And if you I will definitely bring out some mentions about different ways of doing things and things to research about, but at the end of the day, it is all maths, and a lot of it is just very specific knowledge math, so I'm not gonna go over it that much in detail, because it's just what it is, right? So okay, so I don't even know how to honestly approach this problem in a good way for as a teaching thing. No, I'll just go over my way of doing it. Was that I kind of just I have a notebook during the contest, and I still do, but I had it during the contest as well, and I was just playing around with some numbers. Some observation that you might not have noticed in the first try, depending on how you do it, is that you have n people, you have x stages, and yeah, and the y. If you have, okay, let's step back for a second, right? So if you only have n people, x stages, you ignore the y. This is actually pretty straightforward, right? Because for each n person, you could have x stages, so that means that this is just going to be x to the n power, right? And you would be done, and this would not be a hard problem. Maybe, I don't know. Of course, you have to handle the mod and stuff like this, but the y makes it complicated. Why does the y make it complicated? Well, the y makes it complicated because then now your problem is, okay, if there's one group on stage, then y contributes only once, right? Meaning in this case of y is equal to 3, you can only get 3 score once. If there are two bands on stages, if there are two bands on, two groups on, then now it is 3 square, right? So immediately I'm just going to take notes for y'all. Let me step back for a second and just say, naively, you can have what was it, x to the n total number of possibilities, right? Not including score, not counting score, but counting score. The distribution now matters. If we have one group of x people, or of n people, then we have y, the contribution to the answer of that is going to be y. If we have two groups of n people, it doesn't matter what the people is, but and then you have y times y, because each of the group has y, right? So it's 2 to the y, y to the 2, and then same, right? Pretty much. I mean, you get the idea, really. I hope it's going to be y to the cube, right? So then now the problem becomes, okay, right? And it took me a while, so I'm saying this like, okay, I'm skipping over like 10 minutes of just playing around with random silly things, right? And it took me a while to get this, because you watched the live portion. I actually misunderstood. I didn't misunderstand it per se, but I misread it enough that I just didn't read it correctly. In that any performer is assigned a different stage, and the way they didn't really phrase this for me precisely enough. Maybe it is, to be honest, and I just didn't really, I don't know, read it this way the first time, which is that I didn't read it correctly the first time, which is that I thought the performers were non-fungible, right? Or they're not distinct, meaning that they're not distinguishable, right? Meaning that, like, you know, if group A has 3 people, or stage A has 3 people, it doesn't matter which 3. So I did the math that way, and I did competitive. I did a dynamic programming that way, so that wasted some time. But after that, I noticed that, okay, right? So then now, you have this group of people, so, and this is the Y contribution, right? Then the question is, okay, out of the X to the power of N, how many ways are there to have one group of people, 2 groups, etc., right? Well, there are also another, you know, even this has multiple parts, right? Even this has multiple parts because you have to ask how many ways are there to have one group of people on N stages, right? Is N the stage? No, X stages, right? This part's a little bit, I thought it was going to be easier. I mean, and it is easier, but yeah. How many ways are there to have 2 groups of people on X stages, right? And I think, honestly, for me, my combinatoric is actually not as strong as it used to be. And going back to the same mistake that I made earlier, for a little bit, I thought that it would be distinct as well, or it would be not distinct. So the difference is that between whether they're distinct or not, or whether the quote-unquote the order matters, is the difference is that if the order doesn't matter, meaning that they're not distinct, meaning that, okay, let's say we have band ABC and okay, well, this is not one group person. Okay, let's do it under 2 groups. Let's say we have 2 bands. Let's say we have 5 people. We have 2 bands. So then you have ABC in one group, D and E in other, and then this goes on stage 1. This goes on stage 2. I know we're using one index, so this counts differently than this case, right? And this is where order matters. And if you want to say, okay, let's just add another band just to make it even more clear, you know, you have this, then now, like this is another group, right? Oh, I didn't count the number of stages, but let's just say there are 3 stages for this one, right? So yeah, this is another group. This is whatever. This is another possibility, and dot dot dot, right? So all these are distinct, meaning that the order matters, which is another way of saying that, yeah, you have to factor that in as well. And well, the way that you can do it, there are a lot of different ways to calculate this, but basically this is called a permutation, right? So basically this is the number of ways to permutate to get, I want to get the vocabulary exactly right, but I think I'm going to mess it up, to get X distinct stages with K groups of people, right? So that's basically the idea. And there are a couple of ways to calculate this, but it turns out that it just is X times X minus 1, because there's for each of these K, the first group will have X ways to X choices of stages, and then the second group have X minus 1, and then the third group have X minus 2 times dot 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 times, I think, X minus K plus 1. I could be off by 1, but you get the idea anyway, right? Is that yeah, that's the number of distinct ways to with groups of people. And I kind of made a mistake here too, because I thought initially that it was going to be X choose K, which is not this. But we can talk. Well, I bring this up because we'll talk about this in a little bit, in a second, right? And this is if they're not distinctive, or if the ordering doesn't matter, right? So that's basically the idea. Okay, and then the last part then now is that, okay, I guess I don't have to type okay. we have k groups of people, or k bands we want to fill with n people, right? Was it n people? I always forget they don't use good variable name. We want to fill with n people. How many ways are there to do this, right? And a naive thing to think about would be that, okay, well, if k bands, each of them has, we have n people, each of them has k choices, it'll be n to the k. But this is not right, because there are zeros, right? Meaning that, for example, in a very extreme case, we have all n people in one band, then you have one band, you don't have k bands, right? So yeah, and there is actually, like, you can also solve this with inclusion exclusion, right? Because then now it is just equal to this is the number of people in k bands minus the number of people in or number of ways that n people can go to k bands minus you know, something like k minus 1, but yeah, right, something like this, right? Or k times n to k minus 1, right? And the reason why this is the formula is just that, and this isn't done yet, just to be clear, because this is the number of ways to be in k minus 1 groups, right? Kind of. And I say kind of because then now you subtract out too much, because, you know, and this, the way to get this recurrence from here is just because yeah, this is taking one person. So basically now you have how do I say it? So you have k minus 1 groups, right? N people will go to all the k minus 1 groups, except for, yeah, except for you take from one of the groups and distribute them in the other ways, right? So that's how you get the. Did I mess this up? I think maybe I messed this up a little bit. I think this is. I think there's like an n minus 1 somewhere actually. Yeah, this is hard to get right. Sorry, my apologies. But yeah, but the idea here is that, yeah, we take one of the person to put it in the different groups, right? And that's how you kind of, you know, do the subtraction. But it counts out too much, so then you have to add things back in, and this is how you get the inclusion exclusion principle, right? And you can maybe do it this way for sure. Well, I mean, you can definitely do it this way, but it turns out that you could solve this with recurrence, and it turns out that this is actually, yeah, and I kind of have it here, so, I don't know why I wrote it so funkily, but yeah, but it turns out that, yeah, f of nk is equal to f of n minus 1, k minus 1 times k times, or I keep on saying times, plus f of n minus 1 k minus 1, wait, okay. This, right? Which is what I have here. And the idea here is just in a recursive way. You have k bands, so we want to just fill for the nth person, for this particular person, you want to fill it out into the current k band, and we're happy. Or there are k ways to do it, such that one of the band is left empty, right? And that's really the idea. And you kind of yeah. Anyway, and for more of this, actually it turns out that this is the Stirring numbers of the second kind. This is actually a sequence that comes up a lot in combinatorics. Maybe not as much as it used to be, because I think when I was starting out, it came up a lot because not many people know it. But now I wouldn't be surprised that many people know it. And even if people don't know it, this is a relatively, nowadays, an easier formula for people to derive. So people do come up with it all the time. So this is why I'm not surprised that people got it like very quickly, this problem. But yeah, so then now you have this, and you have this, and you just now multiply them all together and then sum it all up. And that's basically it. That's the formula that I have here. So then groups, maybe groups. And the way that I wrote, so this is one way to write it, right? Yeah. This is one way to write it. You could write it another way. The reason why this is one way to write it is that if you do the and it's because I messed up during the contest. But choose x choose I is actually, you know, x factorial over x minus I factorial. Oops. And I factorial, right? So then now to get back the number of permutations, just times it by I factorial. Maybe this isn't that clear. This is the underneath part, right? So you times it by I factorial, so then you get rid of this, which you get this, which is the number of permutation that you get. But actually, yeah, now that I think about it, you don't even need it this way, right? You just kind of do a for loop, really, and that'll be good, right? Because you do a for loop from I to x, and you could do this like in a prefix sum kind of way. So there are definitely different ways to do it, but this is the way that I chose to do it for whatever reason. Scoring, as I said, so you have I groups, you have y to the I. So this one's relatively, you know, more straightforward, and we do a mod pile, keeping in mind the mod, you know, because otherwise it gets expensive. And all these other ones, yeah, I mean, this is just a choice. This is binomial. It took me a while. I don't know why. I was just struggling today. But yeah, and I didn't even need it, I guess, because I needed the for loop. So, but yeah, this is binomial distribution is x minus 1. You know, I'm not going to go over it in this problem because it's actually not that necessary, like I said, because you can just you just do this thing, which is actually just x times x minus 1 times ... x minus I plus 1 or something like this, right? And you can do this way, straightforward way from here. Just do it in reverse or something, right? Like you could calculate this very quickly, but I don't know, during the contest I was just crazy. But yeah, and this is the Stirring number of the second kind that we talked about, which is here, which is these base case. And yeah, and you just kind of go this, and then the answer is just yeah, you sum up all the answers for the number of groups, and then you mod it a couple of times just in case, and that's pretty much it. What is the complexity here, right? So this is I guess this could be confusing looking. I mean, this is kind of confusing looking because this looks like it could be n square, and even the way that I did this is n square. But keeping in mind that there are a lot of overlapping problems, right? So the sum of all the inputs are actually n square for both these two sets of numbers. And in fact, you could pre-calculate them as well because they don't change over different problems. So so that's why I have this. Let me also just add a note for Stirring. Did I spell that incorrectly? I think I did. And this is just factorial. I'm not going to write it. And that's pretty much it. So this is going to be at most 1,000 square due to the Stirring number calculation. And other stuff, at least the way that I did it. And that's pretty much it. I did get a 5-minute wrong penalty just because it doesn't show up for whatever reason. Because it runs out of memory because I didn't put it outside. And once I put it outside, it's fine. I could have also did this bottoms up. This is not a hard thing to do bottoms up. But yeah, as you can see, it took me like 40 minutes almost. Or maybe more. I just can't do math. Because I was just struggling with random things. But yeah. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye. Which is good. Alright, that's YOLO. Hopefully not too... Okay. A little bit slow, but we got there. Alright, Q4. Whew. Alright. You're given 3 integers and X and Y. X stages. Some stages. 1 to Y. Return it. What? Alright, mod. I don't know what's going on. Okay. I think my eyes are not sensitive enough. Okay, so 1, 2, 3 means that. What does that mean? The score. Any band is what it is. 2 ways to assign a stage to the performer. Oh, the event can take place. So each person can. I would think a lot of the small people would have gotten it, but okay. So the score part means each number of groups times Y, so that's fine. N is only equal to 1,000, so it's probably DP. Right. So basically we are at okay, so how many people are left and how many stages are left, right? Is that good enough? Yeah, it should be okay. Maybe. Yeah, okay. So then now stage. Okay, so the number of people on this stage can be 0. That's the thing, I suppose. So if take no tick. Okay. So tick is gonna be. So this stage takes a person. So it's gonna be n-1 s-1 times y, because we took a person, but we have to add a boolean thing of just used. If not used, then we can do this. If it is used, then we just maybe take one, and then we also maybe don't take one. Oh no, no, if it's not used, then we take one, but it's this. For the number of combinations, yep, okay, so, and then now this is used, right? Otherwise, we're done, or, well, we could also still be done. So this, you have this thing, anyway. Oh, no, you just skip the thing. Oh, I guess I had it here. I don't. Okay, so this is skip. This is so okay. So we've already used, then we just go n-1 s. Else, if it's already used, then we just keep used. Otherwise, this is also true, right? But when we skip, then we go back to false. True, right? And I think that's really it. Okay, so if n is equal to 0, then we just return 1 because we can't grade the rest of it. If s is equal to 0, do we all have to be assigned? Okay, so every person has to be assigned. So if n is, well, it's not 0, so then that means that we just return 0 because we have people left over. Yeah, I think this is right. I know I'm not doing mod yet. Actually, I should do mod already. X. What is Y? Y is 1,000. We could mod it. Something like this. Takes 3 position. Did I mess up one of them? Oh. Silly. 6, 6. Oh, this is way wrong, but that's fine. Okay, did I make this? Okay, 32 makes sense. So why do I have 6? So I have 5. 5 persons, so 5. Was it? I think it's 32 because it's 2 to the 32. But how do I even? That. Alright, so maybe I'm very wrong. Basically, you define. Oh, it's each distinct. Okay, I have to do the math a little bit differently, maybe. I was doing it in the front. Okay, okay. Let me rethink this. All right. Well, that's not right. Or it's right for a different problem, but not this one. Okay, so each. Then. So each person can be in one of the stages, but then we have to count the number of groups. So that's the problem, right? So 3 to the 3. What's 3 to the 3? 27 times 4. Really? Why is it 687? Oh, 684. I can't even say it. Is it just not 3 to the 3? Oh, so it's no, that's just wrong. Okay, well, back to the drawing board. Okay, okay, so then it's 4 to the number of bands. So because it's 27. All right, let's calculate it. 3 to the 3 is 27, and then technically it's 4 to the 27, but it's not because, well, it's just not right. No, it's the summation. It's not 4 to the 27. It's 4 to the summation of the groups, which is sometimes 4 to the 3rd and sometimes 4 to the 2nd and something 4. So then it's just count the number of ways one group can be formed and summation that. Okay. And they're distinct. Alright, so then for each person, and my math is really bad today. How am I doing anyway? Wow, people are well, okay, I forgot about ChatGPT, but 187. Wow, people are very fast. Oh, it's very ChatGPT-able. Okay, so so it has to be at least 27, but then The y is the hard part. How many of those 3 to the 27 has... there's only one with one group. And then how many of the 27 has 2 groups? And how many has all 3? Well, all 3, there's only 3 ways. Right. So then it's 24. So then that is double checking the math. Four to the 2, 16 times 24. No, the 3 is this. No, that's wrong. So you have one way of all. No, it's not one way because it's unique. So it's actually 6 ways of having one groups because they're distinct. My math is bad. All 3 in one group is 3, so that's 9. 9, 27 is 18. So then now 4 to the second, 4 to the third. So I guess that's how you do it. This is how you do it. 384. $288. I think the annoying thing about this problem is that it's so hard to check for cheating. But okay, that matches up what I expect. But okay. So one way or another. And it matters which stage you're in. Though that doesn't matter. Well, because it is just the number of groups factorial. So 2 factorial 9. What does that look like with that math? Number of groups factorial. Yeah, okay. Because 3 groups. And then just, well, does that help at all? And then 2 groups. Just 9. Then 1 group. Well, it's not factorial. It's okay. So it's not 3 choose 2. It's 3. It's number of permutations, right? So then it is going to be. Well, if it's just one group, then it is 3. If it is 3 groups, number of ways to be in 2 groups, but it's distinct, right? So can I calculate that easier? Number of ways to be in 1. This is also a special case. How many ways are there to be in 1 group? one group is always just going to be and where is two groups? Two groups is tricky. Oh, two groups, is it just two groups is x choose 2 and then 2 to the n. Is that right? And then three groups is we choose, well, it's 2 to the n. Yeah, and then three groups is x choose 3 and then is it 2 to the n? And then 3 to the n. Is that right? We want to apply it to what we just did. Okay, so 3 choose 3 is 1. And 3 to the 1 group is 3. 3 choose 2 is 3 choose 2 is, what is 3 choose 2? Oh, I'm confusing myself. I know it's, okay, it's 3. And then out of those two groups, we have 2 to the 3 to the n. Yeah. Wait, what is n again? N is, no, that's it, doesn't. Okay, so you choose 3 stages, and then each of the person. So 3 to the, that doesn't make sense though, then, right? Oh no, there's 3 stages, so there's 1. Alright, slow down, Larry. You don't need to rush this. You still have 45 minutes. Okay, so you have 1 stage. No, you choose 3 stages, okay. And then, oh, but it's not 3 to the n because every person has, each stage has to be in one of them. You pick 3 of these people to put it into there. So then it's 3n minus 3 times n choose 3 because you select 3 people to select. Does that overcount? I think that overcounts, Larry. Yeah, that double counts. Yeah, that cannot be. Okay, so you choose 3 stages, that's fine. And then, yeah, I think that part is fine, but then how do you enforce that they're all 0? How many of the 3 to the n's have at least 1, right? Get this done. do we ensure each stage has one person to them? Oh, it's 3. That's the thing, is that actually it's 3 factorial, right? But then, how do we make it count such that it is at least 1%? Oh, so it's not 2 to the n. Can I do a math thing? Or like an actual programming thing? 3 to the minus. So, okay, let's say we have 3 to the n, right? Which is wrong, but then we subtract it from the number of ways. Do we subtract it from the number of ways that how many ways are there that the 2 groups will fit? Okay, so we have 3 to the n. But then now okay, the stage part, fine. But now we're saying, okay. Okay, we have 3 people. Okay, so we have to extrude 3 the stages, but then now I think this is, I remember this now. It is, maybe. Yeah, a lot of people got it. Okay. So then now we want to say okay, fine. N people, X groups, X stages. So then now we have for I in range of X. Let's just find out what I can and then we'll figure it out. Right, and then now it is X choose I for the number of stages. Permutation. Yeah. X choose I. How do I do it? Is it X? Is it comp? Let me just X choose I, number of groups, right? And I don't remember how to, okay, fine. Yeah. And then it's just if I see what it is. I should have code for this actually, but and then it is just X times so it is X minus 1. I think there's a Pascal triangle thing, right? I don't know. What am I doing? Right? Is it this? I'm just I am just being really bad right now. Alright, let's just figure out how to choose this. Oh yeah. This is binomial, right? What are you doing, Larry? This is binomial. Right? Alright. Did I multiply? I did multiply. I'm trying to find my old code, honestly. Oh no, okay. Two choose one is 2, 2 choose 2 is... Okay, that's also... I don't know, 5 choose 2. Let's 5 choose 2 anyway. 10? I guess that's right. I'm so not confident in myself today. Yeah, okay, fine. This looks okay. We have to mod it. Okay, yeah. Okay, so then now, so that is the number of groups. And then now we have to figure out how many distinct ways. Is it just it? And then this is just y to the power of groups, right? So this is the scoring difference, and then now the groups is no, it's 4 to the I for the number of groups, for number of distinct groups, and not this is confusing, but yeah, okay, fine, whatever, this is fine. And then the thing is that then now it is number of ways to do this, right? So then the number of non-empty sets. So then now it is, we have n people into I groups. Right, and then the other number should be I don't know why I use a small n, but it is how I'm doing it this time. One, then if n, and then return goal of n. So then now this person can start a new group, maybe. Oops, this isn't right. Something like this? Nope. 6 is right. Which is a start. Okay, so for the 2 cases should be actually pretty straightforward. I'm putting too much stuff. Only half an hour left, Larry. Okay, so for 2 people you have 1. Why do I have 2? if x is already 15. Oh, because groups is 0? Why the group 0? What am I choosing? X, we want, what is x? X is 2. 2, choose 2. Did I do this wrong? 2 choose 2 should be 1, right? Am I really that bad at the binomial? What are the base cases? I'm just like being bad. 2 choose 2, right? What am I doing here? Groups. I, X. Huh? Am I just being dumb? I mean, the answer is yes, don't answer that, but... Why is this group 0? Huh? What? What? Am I printing the right thing? Am I reusing I somewhere? X is 15. Oh, because I'm using X here. So I'm... What? Oh, because I am dumb, I'm dumb. Okay, I mean, it's still wrong, but at least it's wrong in a way that it's not unpredictable. I am just so bad at this. Okay. Okay. So, let's see. Right. So, you have one group. One scoring. No, groups is 2 choose 2. Okay. Did I miss a step? I did miss a step. 2 choose. It's not 2 choose. Is it 2 choose 2? It's the number of ways to have one groups, but then you times it by 2 factorial or something. I feel like that's... Alright, let's just do I feel like that's another formula, but I'm just being bad at it. So it's not choice, it's permutation. And I'm times it back in, but I'll have to rewrite this, but okay. So now this is right. But and just gonna YOLO submit actually. After doing it 1,000. Oh, and 1,000. Okay, it seems fast enough. YOLO. If it times out, there's a lot of easy optimizations, but come on, Leetcode. I mean, this is I'm just a little bit lazy. It's an easy fix, but that's actually kind of crappy. I mean, it's fine, I guess. No, it's not. This is crappy. I don't think I do that much crazy stuff, but I guess we don't clear things. And all these are actually actually, can I just take it outside? Yeah, because mine is the same, right? So and then that, okay, so that takes whatever. But if I have 2 of these, that still takes whatever. So okay, fine. Yeah. And let's optimize this a little bit. This is just, I mean, yeah. So this is actually not a choice, it's a permutation. So then now it is x factorial minus I factorial. Can I fix that? I mean, this is actually a pretty good way of writing it. Yeah, I'm really bad at math today. I'm not surprised that in the beginning I was surprised that people didn't finish it faster, honestly. Number of groups, and then the stirring numbers of non-empty sets. That took me a while to get. Actually, it used to be one of my favorite sequences. It comes up a lot or used to be anyway. Comes up a lot in competitive programming, but yeah. But yeah, still failed due to Leetcode's whatever thing, as it happens. Can I write this in a better way? No, I mean the better way to write this is by using like inverse mod stuff, or modular inverse stuff, which is not great. I mean, if this is fast enough, it's fine. I don't know. I'm just too tired right now. Yeah, but this isn't even a second in Python, so I'm fine. But still. Yeah, I mean, I'm not surprised people got this. Ooh, 500 though, wow. That is actually a lot of people. Oh well. Wait. Yeah, I mean, I should have gotten this quicker. I misunderstood the problem early on. This part, I guess I got. This part was the hardest part, but not really. I just kind of forgot how to go about it. Why is this necessary? I was just kind of slapping it on, but I feel like there should be only one way to do it anyway, right? Like, why is this not... Like, why is this necessary? No, I guess it's not. It's just that I had the random other issue. That's why I was like so confused about it. Because I was updating X by accident. Because I use X for everything and they use X as the parameter, which confuses me, apparently. And then Q3 I had to I had to rewrite, so yeah, it is what it is. I do wonder if oh, I guess I don't have that thing back up. Can I? I have too many random things. I'm wondering if there's like, it loads up a version where, okay. I'm curious whether like top down works, but unlikely. I think it would just run out of memory. Actually, in fact, like that's what happened, right? Like we tested it for n cube and sorry, 3000 squared and ran out of memory. I was going to try to see some of it works, but it's not even worth it at this point. I was too slow on this one too, though. But I had to convert it and be a little bit tighter. Yeah. I don't know. Not a good contest for me, I think. Ultimately, I mean, I did okay. These math contests are pretty tough in the morning when I'm not awake yet. Like programming, I can do, but workout details on these things, maybe I need to be a little bit. My brain needs to warm up. Q3, I probably could have been. Should have been faster. 17 minutes is a little bit slow. Even if you factor in that like 5 minutes I have to do to convert it to the bottoms up. I think I just misread this one a little bit. I have to watch the video that you watched to see where I'm spending the time. Because I think I got so confused about target index for a while. But once I realized that that is actually like a easy lookup, then I don't know, it was fine. It's just that I was doing it very slowly. Yeah, that's all I have for today. I mean, I don't know, just a sloppy day, and a lot of people is getting Q4. I'm surprised not more, to be honest. Just because of ChatGPT, and this problem I feel like it's so easy to ChatGPT. Probably that I'm surprised that. Let me. I'm curious. Oh, I didn't submit. Yeah, I'm just curious whether ChatGPT could get it before I go. But yeah, I don't know. I mean, there probably is a way to do it. There's probably a way to do it. I don't know if this is the right way because it looks odd, and it even has that like fake variable that Leetcode puts in and hoping that you don't catch. But I am curious. Actually, is it right? I don't know. It doesn't look right. I feel like it's missing something, but maybe I don't know. Maybe I am the one who's wrong. Let's take a look. Huh. I'm curious whether it even has this brand. What does this do? This doesn't even do anything. Why is it here? Alright, well. No, so yeah, it didn't look right for me, because otherwise I feel like I would have gotten this very quickly. I mean, you probably can iterate on it, I don't know. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. My explanations are pretty good. Yeah, stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.